Welcome, everyone. Today, we are diving into a crucial security pillar of Microsoft Foundry platform configuration, identity, and access management. We will explore how to secure your GenAI workloads using managed identities and role-based access control, ensuring a true zero-trust architecture. Let's get started. Let's begin by defining identity and access management, or IAM, in the context of Microsoft Foundry. At its core, IAM is the security discipline that ensures the right people and the right applications have the right access to your AI resources. The basics require us to understand two distinct phases: authentication proving who you are and authorization determining what you are allowed to do. Why is this so critical for GenAI? Because our models are interacting with highly sensitive enterprise data. All services within the Azure Trust Boundary must authenticate all incoming requests, including those from the same network. How do we achieve this? We centralize our security through Microsoft Entra ID. For our deep dive, realize that we are shifting away from traditional passwords. In a modern Foundry architecture, we treat the AI application itself as a first-class identity, allowing it to authenticate natively without hard-coded secrets. Take a look at this flowchart mapping the modern IAM request lifecycle. On the left, our AI application or user initiates a request. Step 1 shows this entity authenticating against Microsoft Entra ID. Once verified, Entra ID issues a secure token in Step 2. In Step 3, the application presents this token to the authorization gate of our target resource. This gate checks the permissions assigned to the token. Only if the validation in Step 4 passes does the application finally gain access to the Foundry AI resources. This separation of authentication and authorization is the bedrock of cloud security. To secure our authentication phase, we utilize managed identities. What is a managed identity? It is an automatically managed, credential-less identity generated in Microsoft Entra ID specifically for your cloud applications. The basics are transformative. Your developers no longer need to manage passwords, rotate API keys, or hide connection strings in code. Why is this a game changer? Because historically, leaked credentials and poorly stored secrets have been the primary vectors for devastating cloud breaches. How do you implement it? You simply toggle on a system-assigned or user-assigned identity on your compute host. Diving deeper into best practices, the rule is strict. Whenever available, use Azure Managed Identities to authenticate your services. By doing so, the Azure platform itself completely abstracts the underlying cryptographic certificates, automatically rotating them in the background without any human intervention or downtime. This diagram illustrates the elegance of managed identities. At the top left, our compute host running the AI web app has a managed identity enabled. Notice the connection to Microsoft Entra ID. Entra ID is quietly auto-managing all the hidden credentials in the background. When the app needs to call a backend service, it requests an access token directly from the local host instance, which talks to Entra ID. Entra ID returns a highly secure, short-lived token. The application then uses this token to authenticate seamlessly to resources like Azure Key Vault or Azure OpenAI. There are zero passwords stored in the application's configuration. With our managed identity authenticated, we must now tackle authorization using role-based access control, or RBAC. What is RBAC? It is Azure's native authorization system that provides fine-grained, policy-based access management to your resources. The basics of RBAC involve combining three elements: the security principle, which is our managed identity, the role definition, what actions are allowed, and the scope, exactly which resource the role applies to. Why do we rely on RBAC? To rigorously enforce the principle of least privilege. We want to grant only the absolute minimum access required for an action at a particular scope. For our deep dive, this means abandoning lazy security practices. You should never assign broad, sweeping roles like contributor to an AI agent. Instead, you must assign highly specific, data plane roles designed for AI workloads, restricting the agent to exactly what it needs and nothing more. Let's break down the anatomy of an RBAC assignment using this block diagram. Inside the RBAC assignment boundary, we see our three necessary pillars. First, the security principle, represented by our managed identity. Second, the role specifically, the cognitive services OpenAI user role, which allows inference but denies administrative changes. Third, the scope, which limits this power exclusively to one specific OpenAI resource, not the whole subscription. When these three elements align, they form a strict policy. The system evaluates this policy, leading to access granted and ultimately allowing our secure inference API call to succeed. If any of these three pillars are mismatched, access is hard-blocked. Let's apply this architecture directly to the core components of a generative AI application. What does this look like? We must securely bind our application to both the large language model and the vector search database. The basics dictate that our application's single managed identity will require multiple, distinct role assignments. Why do we separate these? To segregate duties. If we use separate, fine-grained roles, we limit the blast radius. A compromised component cannot seamlessly take over the entire data estate. How is this executed? As outlined in our architectural guidelines, we configure Azure RBAC to explicitly allow the bot's managed identity to access the OpenAI resource and then separately authorize it for the AI search resource. Diving deeper into the exact implementation, we assign the Cognitive Services OpenAI user role to allow prompt execution, and we assign the Search Index Data Reader role to allow knowledge retrieval. This locks down the data boundaries flawlessly. This flowchart visualizes our secure GenAI topology. Our AI Copilot application acts as the origin, leveraging its system-assigned managed identity. This identity is verified by the identity provider, Entra ID, in the center. Notice how Entra ID routes the permissions. Down one path, it applies the Cognitive Services OpenAI user role, allowing the application to securely interact with the Azure OpenAI endpoint for inference. Down the second path, it applies the Search Index Data Reader role, permitting the app to query Azure AI Search for RAG retrieval. The app has exactly the permissions it needs to function, managed entirely without passwords. As we secure our applications, we encounter a critical limitation of standard RBAC that we must address: document-level security. What is this? It's the requirement to restrict data access not just at the database level, but down to the individual document or row. The basics are that assigning a role like Search Index Data Reader gives the application's managed identity access to read the entire search index. Why is this a problem? Because in an enterprise, an HR manager and a junior employee should not see the same documents when they ask the Copilot to search the index. How do we solve this? We capture the end-user's token and pass it through to the data tier. The deep dive reality here is that per-user access over search results is not natively supported through Azure role assignments alone. As an architectural workaround, we must implement security filters inside Azure AI Search that actively trim results by user identity, stripping out documents the specific requester shouldn't have access to. Let's trace how we achieve document-level security in this flow. An end user sends a request. The application authenticates them, explicitly capturing their user identity. The app then uses its own managed identity, via RBAC, to query Azure AI Search. The search engine executes the query against the full index. However, before returning the data, the process hits the critical orange diamond: security filters apply. Here, the engine compares the captured user identity against the document access control lists. It automatically trims out any unauthorized documents. Only the filtered, safe results proceed to the LLM for grounding, guaranteeing that the AI never hallucinates using restricted information. We have secured our application runtime, but what about the deployment process? We must secure the MLOps pipeline itself using federated credentials. What does this mean? It means securing the CI/CD platforms, like GitHub Actions, that physically build your Foundry environments. The basics dictate that we need to automate our deployments without relying on static, stored secrets. Why? Because if your deployment pipeline uses a hard-coded service principal password and your repository is breached, the attacker gains full control over your Azure estate. How do we prevent this? We use OpenID Connect to establish a federated trust between GitHub and Microsoft Entra ID. In our deep dive, we see this in action. Instead of a password, the GitHub action dynamically requests a short-lived token from Entra ID based on this trust. The pipeline uses this temporary token to execute AZ login, allowing it to securely provision resources and map out RBAC assignments automatically, maintaining a zero-trust posture from code to cloud. This sequence diagram maps out the secure, passwordless deployment flow. It starts with GitHub Actions reaching out to Microsoft Entra ID, requesting a token based on a pre-established OpenID Connect federated trust. Entra ID verifies the repository and issues a short-lived access token. GitHub Actions then executes AZ login using this temporary token. Fully authenticated, it instructs Azure Resource Manager to deploy the Foundry resources and dynamically assign the strict RBAC roles to our managed identities. The deployment is completely successful, and at no point was a static password ever exchanged or stored. Let's crystallize this with a real-time use case. Consider Prosware, an enterprise deploying an internal support agent designed to answer questions using proprietary, department-level data. The basics: this agent requires an Azure OpenAI endpoint for its reasoning engine and an Azure AI search index to retrieve the internal documents. The why is clear: security is paramount. This agent absolutely cannot possess a master password or connection string that, if leaked, would compromise the entire organization's data. How does Prosware solve this? They architect the solution strictly utilizing managed identities and RBAC. Taking a deep dive into their implementation, they enable a managed identity on the agent. They assign it the search index data reader role, proving it can only read, never write or delete data. Furthermore, because department data is siloed, they implement those crucial identity-trimmed security filters we discussed, ensuring the LLM only ever grounds its answers in documents the requesting employee is explicitly authorized to view. Let's follow the data flow in Prosware's secure architecture. We have two users, an HR employee and an IT employee, both accessing the same support agent web app. The app uses its managed identity and RBAC permissions to query Azure AI search securely. However, look at the branching logic inside AI search. The engine detects the specific user's identity. For the HR employee, the HR filter routes to the HR documents, sending only that context to Azure OpenAI. For the IT employee, the IT filter routes to the IT documents. The underlying infrastructure ensures that cross-department data leakage is cryptographically impossible, satisfying the strictest enterprise compliance requirements. Our final slide addresses the ongoing operational lifecycle, monitoring, and auditing access. What does this entail? It means continuously observing how our managed identities are actually utilizing their assigned RBAC permissions in the real world. The basics involve enabling diagnostic settings across your entire AI estate to capture authentication requests and data access logs. Why is this a non-negotiable requirement? Because setting up RBAC is not a set-it-and-forget-it exercise. You must actively verify that your least privilege policies are working and detect anomalies to maintain governance compliance. How do we do it? We stream all logs from Entra ID, Azure OpenAI, and AI Search directly into Azure Monitor. For our deep dive, this observability allows security teams to run automated queries. If a managed identity suddenly attempts to query an out-of-scope resource, Azure Monitor catches the RBAC denial in the logs and instantly triggers a high-priority alert, allowing you to mitigate misconfigurations before any data is compromised. This final architecture diagram illustrates our security observability loop. All managed identity activity feeds directly into our Azure OpenAI logs and Entra ID auth logs. These streams merge into a centralized Azure Log Analytics workspace. Sitting on top of this data is the Azure Monitor Alerts engine. For normal, permitted access, the data feeds gracefully into our compliance dashboards for regular auditing. But if the engine detects an anomaly such as an RBAC denial indicating an identity trying to overstep its bounds, it immediately routes to the red box, triggering a security team incident. This ensures your Foundry environment remains impregnable and fully auditable at all times.
Welcome to quicktechie.com. So just type in quicktechie.com here. Then you can go through the material which is provided by Quicktechie. So we have first of all video courses which you can go here and you can find the various video courses across the technologies as well as finance domain. So if you see in Microsoft, we have 8 programs currently running. Next, you can go through the ebooks available. So all the ebooks which are in PDF format today, and you can download this. So let me go through Microsoft certification ebooks. You can click on any of this and you can see this is the PDF available for you to download. So these are the premium ebook mostly available on quicktechie.com platform only. Now the second part is exam simulator. As we primarily focus on the all technology companies and finance domain certification preparation material. So this is company wide listed here and you can go through this. So let me go through the Microsoft one again. You can see this is are all Microsoft related certification. AB 730 exam, if you open it, so you can see here this and all the practice papers are available here. Today we have a 5 practice paper. So click on the first practice paper. It would load the questions. You can answer this question. This is way you can answer it and you can move to the next question. Now third material we wanted to highlight is an audiobook. So we started recently with the audiobooks as well, which you can listen on the go, and various technology wise ebooks are available. And at the last, this is our alumni. These people who are subscribing to our courses and this platform, they are all listed here. And at the end, I wanted to tell you, if you find any course or training or certification preparation material which you want to get us prepare for yourself, please put on the comment section. If you're watching on YouTube, on Udemy, or on this platform itself, quicktechie.com, then please put the comment, or you can even send an email to using this contact us options here. You can directly do the WhatsApp message. You can call us on this numbers as well.